Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about the development of surfaces of solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now the today's discussion will be about the development of a hexagonal prism using parallel line development method. So let's read out the statement first of all. We are required to develop the lateral surface of a regular hexagonal prism having side of base 35 millimeter. That is, here we have hexagonal prism with the edge of the base is equal to 35 millimeter and the axis height is given to us as 60 millimeter, and this right regular hexagonal prism is resting with its base on the horizontal plane such that one of its edges is perpendicular to the vertical plane. So one of the edge of this hexagonal prism, as it is resting on the ground on its base, it is perpendicular to the vertical plane, and this prism is having a cylindrical hole of 40 millimeter diameter drilled centrally with the axis of the hole being perpendicular to the vertical plane. So this hole has been drilled centrally onto the axis, that is the axis height is equal to 30 millimeter. So the center of this hole will be 30 millimeter above its base, or it will be 30 millimeter from the top, you see vertical edge over there, from the top corner of the vertical edge, right? So this is at the center. And another thing, this hole, it is a through hole which passes through both of these, you see faces over there, from the front face as well as the back face. So if you look at the back face, the hole will be passing through the middle of the axis, and from the front side also it is passing through the middle of the axis, so that this axis of the cylindrical hole, this happens to be perpendicular to the vertical plane. And another thing, the center of this hole, it will be lying on this vertical edge, that is this longer edge is going to contain the center point of both the holes over there. Okay, so this is the way the hole has been drilled into this hexagonal prism. So we will be drawing the lateral surface development of this hexagonal prism. Now since we are given that this particular hexagonal prism is resting onto the ground on its base, so if we are going to look at this prism from the top side, that is the top view, so in the top view a hexagonal projection will be obtained on the horizontal plane, which will represent the true shape of the base or true shape of the top face. So let us work out which one of the orientation will be appropriate, which fits into the current situation. So if we draw the hexagon in this orientation below the XY reference line, then we will find that none of the edges of this hexagonal base, it will be perpendicular to the vertical plane. So here we have one edge parallel to VP, but we require one edge to be perpendicular to the vertical plane. So this position of the hexagon is discarded, which is incorrect. And if we locate our hexagon in below the XY reference line in this orientation, then we will find that not only one but two edges of the base, they will happen to be perpendicular to the vertical plane. So this is the appropriate position of the hexagon which has to be drawn below the XY reference line. So here you can check. So these are the vertical edges. So hexagon has been drawn such that one edge happens to be perpendicular to the vertical plane, and these are the vertical edges. 1A, it is this one, 2B, it is this one, 3C, 4D and 5E and 6F over here, right? So 1, 2, 3, 4, this is 1, 2, 3, 4, 5, 6. These are the points of the top face. A, B, C, D, E, F, these are the points of the bottom face or our base. And this is a hole, you see, this is a hole which has been drilled centrally in such a way that it cuts the axis at a midpoint over here. And another thing, that this hole has been drilled centrally and the axis of this hole happens to be perpendicular to VP. So we are going to get the front view seen as a circle over there, and this center will lie at the edge of the intersection. You see, this is the edge of the intersection of two rectangular faces over there, right? So over here we are going to get the formulation of a circular front view corresponding to the hole. Now let us start drawing the projections of this hexagonal prism. So step number 1, we are going to draw the hexagon in this orientation as we have discussed, because in this orientation one edge happens to be perpendicular to the vertical plane. Now the edge of the hexagon, this happens to be 35 millimeter, and the vertical edges of the hexagonal prism, they are 1A, 2B, 3C, 4D and 5E and 6F over here, right? Now we are going to join the diagonals so that the axis can be located. So once we join all the three diagonals, so this is the axis point which has been located. So axis point is O and O1. O point lies at the top face of the hexagonal surface, and O1 point lies at the base. So corresponding to the base shape, that is the hexagon, O1 will be lying onto the ground. So we have drawn the axis. Now let us draw the projectors from the top view so that we can obtain the front view over here. So axis length 60 millimeter we have drawn. Now we can draw the front view over here. Now this is our front view, and please see, O dash lies at the top and O1 dash lies at the bottom face or the base over here. Now corresponding to points 2 and 1, the front view of the top face, we get 2 dash 1 dash. Corresponding to the points 3 and 6, we get front view 3 dash and 6 dash. Corresponding to the points 4 and 5 of the top face, so we get 4 dash 5 dash over here. Similarly, corresponding to the base points, so B dash and A dash, if we draw projector through B dash and A dash, so front view on the horizontal plane on the XY reference line, we are going to get the points B dash A dash. Similarly, you draw projector through C and F, the front view will be obtained on XY line as C dash F dash. And similarly, you draw projector through D and E, so the front view gives you D dash and D dash at the XY line. Now here one thing needs to be remembered, that is the projection. You see these three edges, A1, 1A, 6F and 5E, they are lying on the back side, and their projections in the front view should be represented by the hidden line. That is these vertical edges 1 dash and A dash over here. Similarly 6 dash and F dash over here, and the projector next one, that is 5 dash and E dash projector over here. So all these projectors, they should be drawn dotted, but these projectors corresponding to these vertical edges, they have been overpowered and covered by these vertical projections, that is 2B, 3C and 4D. So the projections, front view projections corresponding to these vertical edges, they are going to overlap with the dotted line or the hidden line projections corresponding to these three vertical edges. So we can say that projections 2 dash, B dash, they will be represented by a solid line, and they are going to cover up, they are going to overpower the hidden line projections corresponding to the edge 1 dash, A dash. Similarly, the projections corresponding to 3 dash, C dash, they will be represented by a solid line, and they will be covered by the projections made by the edge 6 dash, F dash in the front view, which will be dotted one. Similarly, the projections made by the vertical edge 4 dash, D dash, that is this one, they will be covering the projections made by hidden line projections made by 5 dash and E dash over here. So we get all the three projectors solid one. I haven't drawn the solid one over here because this portion has been cut by a circular hole over here. So now you see, once I draw the hole, now I have drawn the solid line projection over here after the cutting has been made, right? So initially I did not draw these two solid lines because these vertical edges, they were being pierced by, which are the vertical edges which are being pierced by the circular hole? This vertical edge 3C and this vertical edge which is 6F, which is lying on the back side, right? So now I have drawn the solid line projections over here after the hole has been cut. Now you see this hole has been cut, as I told you earlier, at the midpoint of the axis to begin with. This is the first thing. Second, it will be lying on this vertical edge 3C as well as the vertical edge 6F over there. Now having drawn this hole which is having the diameter 40 millimeter, or the radius should be equal to 20 millimeter, I have divided this hole into 12 equal parts. So the circle has been divided into 12 equal parts so that I can get more number of points on the development, and the better projections or the better preview of the true shape can be obtained in the open pattern which will be obtained over here, right? So this is the location of the hole. So with this, the front view has been completed. Now why do we say that front view has been completed? Because the hole has been completed and all the points of the hole, they have been appropriately marked in the front view. Now these points corresponding to the circular hole, because it is a through and through hole, so they should be marked on the back surface, and all these 12 points, they should be appropriately marked onto the front surface. And please, you must note that these are two rectangular faces which have not been touched by this cutting plane. So these portions, they will remain unaltered. So in the development, we will not find any cutting of these surfaces. What are those surfaces? 4DE5 and similarly 12BA. So these are two rectangular surfaces which have not been cut by this particular circular hole, right? So only two slant faces in the front, that is this one, and two slant faces in the back, they have been cut by the circular hole. So let us draw the projections corresponding to these 12 points onto these surfaces over here. So just check, I am going to draw perpendicular from point 1 dash, right? So projection from 1 dash will be drawn. So wherever you see it cuts this surface over here, so here I am going to obtain point 1. Similarly, wherever it cuts this surface, again point 1 will be located. So point 1 will be located on either side, on the front surface as well as on the back surface. So on the back surface it lies here, on the front surface it is going to lie here. Then next one, 12 and 2. If you are looking from this, look at 12 dash and 2 dash from the top. You are going to get 12 and 2 located over here. Similarly 12 and 2 will be located over here. So 12 and 2, they have been marked at these 2 points which are lying on the surface of this particular hexagonal prism, which is a hollow object. It is not a solid object. Third one, 11 and 3. So you are looking from the top at the points 11 dash and 3 dash over here. So you are going to get 11 and 3 at both of these surfaces, front surface and this is the back surface over here. Next, you look at this particular prism from the top. So 10 dash and 4 dash from the top, they will give you 2 points, one over here 10 and 4 and one over here 10 and 4. So onto this corner or the joint, points 10 and 4 will be located both in the front as well as onto the back surface. Similarly, you will be getting 9 and 5 over here on both the surfaces. 8 and 6 you are going to obtain over here, and finally the 7 point will be again located onto the front surface and the back surface. Now one thing we can observe, this surface is uncut. This surface has been cut by this portion, the semicircular portion of this hole, whereas this surface has been cut by this semicircular portion of this hole. So this semicircular portion will be contained by this surface. This semicircular portion will be contained by this surface. Similarly, this surface, that is the back surface, this surface will be containing this semicircular portion of this hole, and then this surface, it is going to contain the left side semicircular portion of this particular hole. So now let us start working out the development using the parallel line development method. Now here you can see in this particular case we have got two things which we need to keep in mind in order to draw the development. Two things are required, that is true length. Please check, true length of the height should be required and the width of the base edge will be required. So both of these things, they are available. Now you can check, we are going to develop this particular hexagonal prism using the parallel line development method, and in this method there are going to be two stretch lines which we are required to draw. You see, two stretch lines, they have been drawn from the two ends of the solid. So this is my solid. From the two ends I am going to draw two, you check, stretch lines over here, and all the lateral surfaces 1A, 2B, 3C, 4D, 5E, 6F, they will be located between these stretch lines over here. So let us now know the height is equal to how much? 60 millimeter, which is true length. What is the true length of this edge? 35 millimeter. So the six edges are there. So if I draw a rectangle, 35 into 6, that is 210 millimeter box I am going to get, 210 by 60 millimeter. So within this, now I am going to mark different edges. I am going to start this development from the end A. Just see, from 1A I am going to start my development over here. So please check, this is my 1, this is my A edge over there. Second vertical edge we have drawn 2B. Third vertical edge we have drawn 3C. Fourth vertical edge 4D. Fifth vertical edge 5E. Then you have 6F and 1A over here. Now you see we are moving in the anti-clockwise direction. So this way, please check one more thing. If I am moving from this side, even though point 1 is lying on the same point over here, but once I open this development, what will happen? From here, this side point 1 will be lying this distance from the edge B, or edge or corner 2 over here. But over here, once I am opening this out, so point 1 here will be obtained very close to point B. But once I am opening this out, this point 1 over here will be getting very close to the point A, which will be lying over here. So this surface has been opened here. This surface will be opened here. So this way I need to open all these, you see, edges over there, so that if point 1 is lying closer to point B over here, but point 1 will be lying closer to point A over here. So even though from the vertical view, it may appear that they are lying very close to each other, but once you open it out, this point 1 and this point 1, they will be located on the two extremes of this particular development. So that once you do the folding, so after folding, this point 1 will be getting at the back side of this point 1, which is located over here. Now we have 12 points corresponding to the circular cross section over here. So this is our circular cross section or a circular hole. So from these 12 points, I am going to draw the horizontal projectors over there onto this pattern which has been obtained over here. So this is my pattern, open pattern, that is unfolded pattern which has been obtained. Now I am going to draw all the horizontal projectors. So what I am going to get, please see, the point 4 will be lying onto this horizontal line. Points 3 and 5, they will be lying on this horizontal line. Points 2 and 6, they will be lying on this horizontal line. Similarly, points 1 and 7, they will be lying on this horizontal line. And 12 and 8, we are going to mark them over here onto this projection line. Similarly, you have 11 and 9, they will be marked onto this projection line, and point 10 will be marked onto this projection line. That is simple. So the height I am going to get through these projection lines. But then one thing I need to remember, because these points, they have to be located, you see, this way also, because the height I have worked out based upon the front view, but the width, you see, distance of point this one 11 and 3, distance of point 12 and 2, distance of point 1 from point 3. So these two lengths I am going to get from the top view. Similarly, the distance of the points 9 and 5 from this vertical edge 3C. Similarly, the distance of the points 8 and 6 from the vertical edge 3C. And finally, the distance of point 7 from the vertical edge 3C. So this will be visible from the top view. Similarly, look at the top face. This is the vertical edge 6F. So this is the vertical edge 6F, which will be at the center. But I need to work out what is the distance of the points 9 and 5. Similarly, 11 and 3 from the 6F vertical edge. So from this edge, on this side and on this side, I have to carry out the marking over there. On this side, which points will be there? On this side, you see points 11 and 3, 12 and 2 and point 1 will be there on this side. Whereas on this side, which points will be there? You see, these points, they lie between E and F. So nearest to the E, point 7 will be there. Farthest away from the F, point 7 will be there. Similarly, nearest to the point F, points 9 and 5 will be there. So nearest to point F, points 9 and 5 coordinate vertical location will be located. Then 8 and 6 will lie little bit further away and point 7 will lie farthest away from the point F. So let us now draw the coordinate locations of all these 12 points from the top view and then transfer those points over here. So please see, one center point is this one, vertical edge 3C. So my circle will be distributed across this particular cross section. This is the vertical edge and these two faces, this face and this face. So this face will contain one semicircle, you see, 2B3C. 2B3C, this face will contain this semicircular portion of the circle, the circular hole. Similarly, 3-4DC, that is this one, 3-4DC. So this rectangular face is going to contain this semicircular. So points corresponding to this semicircle will be located on this face. Points corresponding to this semicircle will be located in this particular face. Similarly, over here, the corner edges, this one, 6F is my corner edge, right? Or it is my folding edge for this particular circular hole. From 6F, you see, you move between E and F. You move between E and F over here. As you move between E and F, my points, you see, 9, 5, 8, 6 and 7 will be located between E and F. That is, this semicircle points, they will be located in this face, that is EF565. Whereas this face is there, which is again been cut by this circular hole. So there, which points are lying between 6 and A or 6 and 1? This semicircle. That is, this semicircle will contain 11, 3, 12, 2 and 1. So this semicircle will contain points 11, 3, 12, 2 and 1 over here. Whereas the points 4 and 10, they will be contained by this. Similarly, 4 and 10 will be contained by this. But another thing, this face is uncut because we have already discussed that face 1, 2BA, it is lying perpendicular to VP. So this face and this face 5, 4, 5 ED. So please check 4, 5 ED. So this rectangular surface has also not been cut. So this has been cut, this face has been cut, this face has been cut and this face has been cut. Let us mark the points corresponding to the circular cross section over here within this range and within this range. My center points are C and F. Please see, my center line, that is the vertical edges which are lying at the axis or the center of the hole, they are 3C and 6F. So all the distances of the other points we are going to mark corresponding to 3C and 6F over there. Let us start marking the points from the top view. So please check distance of 11 and 3. Distance of the point 11 and 3 from this vertical edge 3C, it is this one. Similarly, the distance of points 9 and 5 from the vertical edge is this one. Both of them, they have to be equal, right? So now I am going to measure this distance and this distance. So where this point 11, 3 will be located, it will be located between 2 and 2 and 3, or B and C. So between B and C I am going to locate 11 and 3 at a distance of this much from the vertical edge 3C. Similarly, 9 and 5 will be located on the right hand side, because 9 and 5, they are contained between 3 and 4 or C and D. So this is 3 and 4, and this is C and D. So let me mark those points. This is my center 3C. I have measured these two distances, C3 and C5. Just see, this is C3 and C5. So these distances, they have been measured. So if I say this is 3, so 11 will also lie here. If I say this is 5, so point 9 will also lie on the same vertical edge. So just see, two projectors, they have been joined over here, right? Vertical projectors, they have been created. Next, from 3C, distance of 12, 2 and 8, 6. This will again be equal. So again, now the second marking I can do. Similarly, I can do the marking over here. Distance from 6F to 5, 9 and 11, 3 over here. But again, you can check 5 and 9. They will be lying between E and F. So this is E, this is F. So 5 and 9 will be coming on the interior side. Here it was coming on the farther side. Here it will be coming on the interior side. So 5 will come first and 3 will come next, because we are going to open it this way. So once we open it this way, so this portion will be coming first and this portion will be coming last. So please see, this distance of 5, 9 from 6F, it is drawn on this side. Distance of 11, 3 from 6F, it will be drawn on the other side. So both the points 3, 5 and 5, 3. But the order is different. Here first 3 comes and then 5 comes. Here 5 will come first and 3. Well, as you are moving along, you see 3 will be encountered first, then 5. But when you move from this side, 5 will be coming first and then 3 will be coming. So first 5 and then 3. Then now the next 2 points, just see C2 and C6. So please check. From 3C, I'll measure the distance of 12 and 2. This gives me C2. From here 3C vertical, I measure this distance. This gives me the distance of points 8 and 6. So C2 and C6, they have been plotted. Over here, once again, F2, please check, F2 and F6 will be plotted. But F6 will be coming first because I am moving from this side. So F6 will be coming first and F2 will be coming thereafter. So please see, 6 comes first and 2 comes last. And finally, last one, C1 and C7. So C1 will be on this side. Please check C1, because if you move from B, 1 will come first. You are moving from C, 1 will come first. And then C7. C7 is from 3 you move towards 4 point. From C or 3 you move towards D. So 7 points is going to be encountered last of all. Similarly, 7 will come here first and 1 will come last. You see, C, here you have F7. F7. So as you move from E, 7 will come first. As you are moving from E, 7 will be encountered first, then 6 will be there, then 5 will be there, then 4 and 10, and then 11, 3, then 12, 2, and then 1 will be there at the end. Now, having drawn all these points, now the situation is simple. The corresponding points need to be worked out. So let us start working out the corresponding point. So this is the location of, you see, point 1. So point 1 vertically and point 1 dash horizontally. Wherever these two intersect, we obtain the location of point 1. Next, on to the second line, you see which points they are going to lie, 2 and 12. So let me locate point 2 and 12. So 2 lies here, 12 will lie here, right? Similarly, point 3. This is the vertical locus for point 3. This is the horizontal locus for point 3 dash. This was horizontal locus for point 2 dash. This was vertical locus for point 2. So on the same vertical locus, point 12 will be there. On to same vertical locus, point 11 will be there. Now the point 4, just see, this is vertical locus for 4 and 10. C3 will house 4 and 10. C3. Similarly, F6 will also have 4 and 10 points over here. So C3 will contain points 4 and 10. But where 4 will be there? Draw the horizontal locus through 4 dash. So wherever it intersects 3C, you get point 4. Next is this point. 5 and 9 will lie on this vertical line. So 5 vertical line and 9 vertical line is this. But this is the horizontal line from 5 dash. So wherever these two intersect, this is location of point 5. This is location for 6 and 8. So where is 6 dash? It lies here. So from 6 dash you draw the horizontal projection line. So from 6 dash horizontal line, from 6 locus you draw the vertical line. So you get the location of point 6, and finally 7. So 7 point lies on this locus line and 7 dash lies over here. Now we have understood 6 and 8, they will lie on the same locus line. So 8 point will lie here. Why? Because it is lying on the intersection of the horizontal locus line which is drawn through 8 dash. Similarly, 5 and 9. So this is the horizontal line corresponding to 9 dash. So this is vertical line which is going to house 5 and 9. You see, 5 and 9, they lie on one vertical edge. Similarly, next one is 10. 4 and 10, they lie here on 3C. So on 3C, 4 and 10 will lie. So where does point 10 dash lie? It lies here. So 10 dash lies here. So I am going to draw point 10 over here. Point 11, 3 and 11, they lie on one vertical line. This is the horizontal line corresponding to the point 11 dash. So this is 11 dash. Draw horizontal line through 11 dash. And finally 12. This is the horizontal line through 12 dash. And on this vertical line, 2 and 12, they are going to lie. You see, 12 and 2, they are going to lie on one vertical projector. So you see, the true shape will be an ellipse over here. Similarly, let us work out the points on this side. So here you see, one starts from the end, that is this face. One will lie closer to A. Point 1 lies closer to A, or 1 lies farthest away from 6F. So you see, from 6F, this lies at a maximum distance, 1 point, and closest to the edge A over here. So that is why location of 1 will be on this extreme. Here 1 lies on this side, left side. Here 1 lies on the outermost right side. Then after 1, now we are moving in the other direction. This is the locus of 2 and 12. So 2 lies here, 12 will lie here. Okay. So 2 lies here because the horizontal locus of 2 is this one. So horizontal line projector has been drawn through 2 dash. So just see over here. Similarly, this 2 and this 2 will lie on the same horizontal line. Next, point 3 over here. You see, this is my point 3. So point 3 means this is F3. So 3 and 11. So 3 lies here. 11 will lie corresponding to this line. So 11 is going to lie here. Okay. Then you have point 4 over here. So point 4 means the horizontal line. Horizontal projector through point 4 dash is going to cut this line edge F6 over here. Then this is my point 5, because 5 dash horizontal projector is going to cut F5 over here, right? So this is my point 5. Then this is my point 6, because horizontal projector through 6 dash. Once you draw, so you will be getting point 6 over here. Point 7, this is the vertical locus for F7. So horizontal locus through 7 dash, just check, it is going to lie over here. This is my location of point 7. 6 and 8, they will lie on the same vertical line. So point 8, just see, you draw the horizontal line through 8 dash. So this will intersect the vertical locus of 6 and 8 over here. So point 8 is located here. Similarly, 5 and 9, they will lie on this vertical edge. Where is 9 dash? Over here. So through this locus line, you intersect it with this particular vertical locus line for F5. Just see, this is F5. So this is my point 9 over here. This will give me point 10 because this is the horizontal line through 10 dash, and this is vertical locus for 410. Just see, this is vertical locus for 410. Then 3 and 11, they will lie on the same vertical edge. Where does 11 dash lies? Check. I have drawn a horizontal projector through 11 dash. So see, wherever it intersects vertical locus for 3 and 11, this will give me point 11. And finally, this is my point 12. 2 and 12, they will lie here. Where is my 12 point? 12 dash lies here. You draw the horizontal projector through 12 dash. So we get the final point 12 over here. So this is also an ellipse. This is also an ellipse. So let us join these two ellipses freehand. You can see a perfect ellipse being drawn over here. Now having drawn this ellipse, now the vertical edges which are uncut, they will be joined. So vertical edge 1, vertical edge 2, vertical edge 3, and the two vertical edges which were intersected or pierced by the circular hole, they will be joined. The remaining portion, that is the uncut portion, will be joined over here. So this is the final development of a hexagonal prism which is cut by a circular hole at the center of the axis over there, right? So this is the development we have obtained using the principles of projections of solids, then section of solids, and then the parallel line development method. Okay, so all these three techniques, they have been used to make the development of a hexagonal prism over there. So we will be continuing with the discussion regarding few more cases of the development of surfaces of solid in our forthcoming lectures. So this is all for today. So thank you very much. Thanks a lot.